Okay. Maclaurin polynomials. Have this.
That's the only one I can afford.
Okay. Maclaurin polynomials, and I'll be honest, we're going to look at these a little bit. We're going to work with them a little bit. I always kind of feel like, yes, they fall in the first part of this book, so they fall in the AB portion of this book, but they really kind of lead into the BC portion of Calc, in which, there's Calc AB, there's Calc BC. You guys are doing Calc AB. So you guys are doing the first 2/3 of calculus in general, so to speak. Okay. Maclaurin polynomials lead us towards series, and series is more of a BC topic. Okay, however, we're still going to talk about Maclaurin polynomials and learn a little bit about them. So, Maclaurin polynomial, you will notice there's a generic form at the top of your notes. F of x equals a naught plus a1x plus a2x squared plus a3x cubed, so on and so forth, up into an x of n. Okay, so this will really depend on, there's no set length, it just kind of depends on the scenario of what we're working with, and we'll work with a couple different scenarios today. But you'll notice that your a values, the constant values, are defined. So if it's a sub 0, what I call a naught, that you find by doing f of 0 over 0 factorial. Now, do you remember what that, I read it as factorial. I'm referring to the exclamation point. Do you remember what the exclamation point does in math? Okay, so yeah, traditionally it's multiply out all the numbers below, all the integers, whole numbers, below that number down to 1. Now, 0 factorial is a special case, and it is always defined as 1. Okay, it just has a special definition there. Okay, so when it comes time to find a1, notice it's the first derivative of f, so f prime at 0 over 1 prime, over 1 factorial. In order to find a2, notice it is the second derivative evaluated at 0 over 2 factorial. a3 is going to be the third derivative evaluated at 0 over 3 factorial. So it's always, if you're trying to find a5, then it's the fifth derivative evaluated at 0 over 5 factorial. Okay, so it's always that series there. Now, more typical is what you're going to see when we get down to examples 2 and 3, where we have to find it to a certain degree. This one is already a polynomial, so you'll see something interesting happen here. But let's go ahead and find the Maclaurin polynomial. Now, it's often listed as p of x. Okay, p standing for polynomial. In order to find the Maclaurin polynomial, a of 0. Well, a of 0 was defined as f of 0, officially over 0 factorial, right? And I'm going to go in and we'll fill in details here in a moment. Continuing along. The next one would be a1 times x to the first. So how is a1 defined? The first derivative at 0 over 1 factorial, and then notice it's multiplied by x to the power of 1. Officially, I guess we could say that first one was x to the power of 0, because when it's x to the power of 0, the x doesn't exist. Here's x to the first, plus, and we keep going, right? So next one is going to be the second derivative, evaluated at 0, over 2 factorial, and that's going to be times x to what power? X to the second. Now, if you're told a certain number of degrees, that's how far you go. In this case, we need to stop and look for a moment. In order for this to work, we have to be able to find derivatives. Well, we already have f of x over here. Yeah, the highest power is x squared. So we're not going to be able to go past second derivative here, is what's going to happen. And what I was going to show you. So what is the first derivative of 2x squared plus 3x minus 4? 4x plus 3. So we'll be able to put in 0 and evaluate there. What is the second derivative? 4. So if we did the third derivative is just going to be 0, and every other derivative is just going to be 0. So we can only go as high as the highest power here, which is x squared. Okay, let's do some math. F of 0. When we put in 0, what do we get here? Negative 4, because it's 0 plus 0 minus 4, so negative 4 over 0 factorial, which I said is defined as 1. Plus, okay, now we're going to do the ones. The first derivative evaluated at 0. What's the first derivative? First derivative at 0 is going to be 4x plus 3, but put in 0 and you're going to get just 3, right? 4 times 0 plus 3 is 3. Over 1 factorial. What's 1 factorial going to be? 1. And then it's times x to the first. Okay. Plus. Now it's the second derivative at 0. What's my second derivative evaluated at 0? 4. Over 2 factorial. What would 2 factorial be? 2, because 2 times 1 is 2 times x squared. Clean that up. What does this look like cleaned up? The original, once you do the math here, negative 4 plus 3x plus 2x squared. Now, it is the original because the original was a polynomial. Okay, if you look at this, f of x equals 2x squared plus 3x minus 4, this is a polynomial. When you get down to looking at examples 2 and 3, which are e to the x and cosine x, they're no longer polynomials. Okay, so anytime you're given a polynomial, if you do the right steps, it should work out to be the same polynomial. So this is more, I'll be honest, example 1 was more an exercise of how does this work? Because it's just going to work out to be the same. Okay? Now, example 2, is it going to work out to be the same? No. But at least I gave you a little exercise of how that all looks. So let's go try example 2 now. This time it says find the Maclaurin polynomial of degree 4 for f of x equals e to the x. So that means as we write this out, we're going to write out up to x to the 4th. So, p of x. We're starting with degree 0, the degree 0 term, right? So that means I'm going to do f of 0 over 0 factorial. Officially, it's times x to the 0. I just don't usually write that. Plus, then for the first power, it's going to be the first derivative, evaluated at 0, over 1 factorial times x to the first. Plus, second derivative at 0 over 2 factorial times x to the second. Are you okay with how I'm doing this? Can you do the next one? Okay. F triple prime of 0 over 3 factorial, x to the third, and one more, f, the fourth derivative, I don't know, is that quadruple prime, over 4 factorial, x to the fourth. Okay, there's your whole polynomial written out. As you get used to this, you may not necessarily write it all out like that. However, I don't know, there's advantages to it. Okay, f of 0. That means I'm going to be doing e to the 0 over 0 factorial. And what do we say 0 factorial is? 1. Now, and I'll go through and clean this up on the next step. What is e to the 0? 1. Because anything raised to 0 power is 1. Okay, I'm going to go ahead and write this step out, and then I'll go through and clean up. Okay, f prime of 0. What is the derivative of e to the x? E to the x. Evaluate at 0. It's e to the 0 again, isn't it? Over 1 factorial. What's 1 factorial? 1 times x to the first. Okay. What about the second derivative? E to the x, which is e to the 0, over 2 factorial. What's 2 factorial going to be? 2 times 1, which is 2, times x squared. What about the third derivative? E to the x, evaluate at 0 is e to the 0. What would 3 factorial be? 6, right? Because 3 times 2 times 1, x to the third. Plus, what about the fourth derivative evaluated at 0? E to the 0. What would 4 factorial be? 24. Because basically you're taking 3 factorial and multiplying it by 4, right? Or 4 times 3 times 2 times 1. Okay, there's a couple different ways we could write this answer. Obviously, we would not leave all those e to the zeros, right? Anything raised to 0 power is 1, so those are all 1s. 1 over 1 is 1. Plus 1 over 1 x to the first, x. What about e to the 0 over 2 x squared? Okay. You can say 1/2 x squared. You could also say x squared over 2. Okay. E to the 0 over 6 x cubed. 1/6 x cubed. And right, 1/24 x to the fourth. Now, depending on what you're doing with this, depending on the scenario, this would be one way to write the answer. Okay. The other way to write the answer would be if instead of multiplying out the factorials, leaving the factorials in the denominator. Okay. Sometimes you need to multiply those factorials out because there's cancellation, there's simplification. Other times, there's not. So, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial. And again, there are some advantages there of seeing this setup. Notice how my powers and my factorials match in this particular problem. Okay, you will see lots of variations of this format when we work with Maclaurin polynomials. And that was for doing a degree 4. Okay. Questions on how we did that or anything like that? Okay, let's try, I believe, one last one. Example 3. Find the Maclaurin polynomial for degree 6 for f of x equals cosine x. And keep in mind, guys, this polynomial that we just used is an approximation of e to the x. Okay? This is going to be an approximation here for cosine x. Now, what's going to happen when we take the derivative of cosine x? Is it going to be the same thing over and over like e to the x was? No, we're going to need the first 6 derivatives of cosine x, aren't we? And I think before we get started, I'm going to set up a chart over here. I'm going to have n be my first column, fn of x be my second column, and fn of 0. In other words, just going ahead and getting all the information I need. And if you think about it, we always start with f of 0, then we do first derivative, second derivative, so on and so forth. N is going to represent all those derivatives. So I'm going to label my n column 0 through 6. So 0, 1, 2, 3, 4, 5, 6. Okay. Fn of x. So that would be just, we don't talk about being the 0 derivative, but the original function. And the original function was cosine x, yes? Let's go ahead and fill in this middle column. So when it says n is 1, that means I'm asking for the first derivative. What's the first derivative of cosine x? Negative sine x. This is where we decide how rusty are we after Christmas break with these derivatives, right? Okay. f2 of x. So this is going to be the second derivative. Or in other words, what's the derivative of negative sine x? Negative cosine x. And this is where my brain says the derivative of sine is cosine. So the derivative of negative sine is negative cosine. However your brain works it through, right? Okay. Third derivative. What's the derivative of negative cosine?
Positive sine.
Okay, what'd you say?
Positive sine x.
Yes, positive sine x. Because normally the derivative of cosine is negative sine. So the derivative of negative cosine is positive sine. Okay. Next derivative. Derivative of sine is cosine. Derivative of cosine. Negative sine x. Derivative of negative sine x. Negative cosine x. And we can keep going, but that's all we need because it asks us for degree 6. Have you guys figured out with the when you're doing derivatives of cosine and sine, they go in a patterns of 4. Once you do 4 of them, then you're going to go back to the original. Or I guess it'd be the original in 3 derivatives. Your 4th derivative takes you back to the original problem. So, okay. If we want, we could go ahead and put our 0 in here. We could also wait to do it till later. What is cosine at 0? Cosine of 0. Cosine of 0 is 1. What is negative of sine of 0? What is sine of 0? 0. Okay. Negative cosine of 0. Negative 1. Sine of 0 again? 0. Cosine of 0, 1. Negative sine of 0, 0. Negative cosine of 0, negative 1. Does everybody have their own way they figure those out? I don't care how you do it, whether you think about the graph, whether you think about the unit circle, so many different ways to do that, but okay. Let's try the Maclaurin polynomial to degree 6. So, p of x equals, can we take shortcuts here since we've already got some of this filled out? The original function, evaluated at 0, is going to be what? 1 over 0 factorial. Plus, okay, now we need the 1's, right? So the first derivative evaluated at 0 is going to be 0 over 1 factorial x to the first. Plus, now we're going to do the seconds. What was the derivative, the second derivative at 0? Negative 1 over 2 factorial x to the second. Okay. 3's, the third derivative, 0 over 3 factorial x to the third. Plus fourth derivative was 1 over 4 factorial x to the fourth. The 5's, 0 over 5 factorial x to the fifth, and the 6's. Negative 1 over 6 factorial x to the sixth. Now, I'm not saying you had to do the chart first, but I think it makes this part a little quicker. We would have had to figure it out eventually. Okay, what happens when we start doing some cleanup here? Okay, the ones that have 0 in the numerator are zeros, yes? Which happens to be all the ones that have odd powers. Okay, 1 over 0 factorial is going to be 1. Then it's plus negative 1 over 2 factorial x squared. I'm going to write that as minus x squared over 2 factorial. And then what's the next one I have? Plus x to the fourth over 4 factorial. And the last one I have? Notice it's going to be minus x to the sixth over 6 factorial. Okay. Could you keep writing that if, do you see a pattern here? Obviously, when you're writing the Maclaurin polynomial for cosines, it's only going to be even powers. My signs are alternating, right? And so, yeah, there's some shortcuts you could do once, given the right situation. I believe when you do sine, does sine work out to be odd powers? I don't remember. I think you'll find out in homework. Okay? So, again, know how to set this up, know how to work it all out. Don't just memorize it. Because when I ask you to do this on a test, I will be looking for more than just a memorized answer. Okay? questions? Yeah, that's all the notes I have. Crazy, I know.
Can we see our tests from Friday?
We could possibly do that.